GenAI and MLOps Part 20. This episode has 8 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. How do you monitor ML model accuracy? Here's a strong way to approach it. ML model accuracy in production is monitored by continuously comparing model predictions with actual outcomes and tracking performance metrics over time. Common monitoring metrics include accuracy, precision, recall, F1 score, ROCOC, RMSE or ME for regression models in production systems. We also monitor prediction latency, error rates, confidence scores, data drift, concept drift. The monitoring process usually involves 1. Collecting prediction logs and actual labels. 2. Calculating metrics periodically. 3. Comparing metrics against baseline thresholds. 4. Triggering alerts if performance degrades. We typically build dashboards and alerting systems using Prometheus, Grafana, evidently AI Labs, MLflow if accuracy drops below acceptable thresholds. Retraining pipelines or rollback mechanisms can be triggered automatically as part of the MLOps workflow. Nice. Let's continue. Question 2. What are model performance metrics? Here's a strong way to approach it. Model performance metrics are measurements used to evaluate how well a machine learning model performs on a given task. The choice of metric depends on the type of ML problem. For classification models, accuracy, percentage of correct predictions. Precision, how many predicted positives are actually correct. Recall, how many actual positives are correctly identified. F1 score, balance between precision and recall. ROCOC measures classification performance across thresholds for regression models. ME, mean absolute error, average absolute prediction error. MSE, mean squared error, average squared error. RMSE, root mean squared error. Square root of MSE r to the power of 2 score measures how well predictions fit actual values in production MLOps systems. We also monitor operational metrics such as prediction latency, throughput, error rate, drift metrics, resource utilization. These metrics help evaluate model quality, reliability, and production performance continuously. Great. Moving on. Question 3. Difference between precision and recall? Here's a strong way to approach it. Precision and recall are classification metrics used to evaluate how well a machine learning model predicts positive cases. Precision measures how many predicted positive cases are actually correct. Precision equals frac TP. TP plus FP. High precision means fewer false positives. Example, in spam detection, high precision means emails marked as spam are actually spam. Recall measures how many actual positive cases the model correctly identifies. Recall equals frac TP. TP plus FN. High recall means fewer false negatives. Example, in fraud detection, high recall means most fraud cases are successfully detected. In simple terms, precision focuses on prediction correctness, recall focuses on capturing all actual positive cases. There is usually a trade-off between precision and recall depending on the business use case. Alright, next question. Question 4. What is F1 score? Here's a strong way to approach it. F1 score is a performance metric used in classification problems that combines both precision and recall into a single value. It is especially useful when the dataset is imbalanced and we need a balance between false positives and false negatives. F1 equals 2 times frac precision times recall. Precision plus recall. The F1 score ranges from 0 to 1. 1 means perfect precision and recall. 0 means poor model performance. Example, in fraud detection or medical diagnosis, where both missing positive cases and incorrect positive predictions are important, F1 score is often preferred over accuracy. In simple terms, F1 score provides a balanced measure of model performance when both precision and recall matter. Let's keep going. Question 5. Explain ROCOC. Here's a strong way to approach it. ROCOC is a classification performance metric used to measure how well a model can distinguish between positive and negative classes. ROC stands for Receiver Operating Characteristic Curve, and AUC stands for Area Under the Curve. The ROC curve plots true positive rate, recall, false positive rate at different classification thresholds. TPR equals frac TP. TP plus FN. FPR equals frac FP. FP plus TN. AUC measures the overall ability of the model to separate positive and negative classes. AUC equals 1 perfect classifier. AUC equals 0.5 random prediction. Higher AUC indicates better model performance. ROCOC is especially useful for evaluating classification models with imbalanced datasets because it measures performance across all thresholds instead of a single accuracy value. In production ML systems, ROCOC is commonly used for fraud detection, medical diagnosis, recommendation systems, and risk prediction models. On to the next one. Question 6. What is model latency? Here's a strong way to approach it. Model latency is the time taken by a machine learning model to receive an input request, process it, and return a prediction response. It is usually measured in milliseconds or seconds and is a critical performance metric in real-time ML systems. Total latency can include data pre-processing time, network communication time, model inference time, post-processing time. Low latency is important for applications such as fraud detection, recommendation systems, chatbots, autonomous systems, real-time analytics. High latency can negatively impact user experience and business performance. In MLOps, latency is monitored continuously using observability tools and optimized through model optimization, GPU acceleration, caching, efficient feature retrieval, auto-scaling, high-performance serving frameworks. Common monitoring tools include Prometheus, Grafana, OpenTelemetry. Maintaining low latency is essential for reliable and scalable production ML systems. Good. Here's another one. Question 7. What is model throughput? Here's a strong way to approach it. Model throughput is the number of prediction requests a machine learning system can process within a specific period of time. It is usually measured as requests per second, RPS transactions per second, TPS inferences per second. Throughput indicates the processing capacity and scalability of a model serving system. Example: if an ML inference service can handle 5,000 prediction requests per second, its throughput is 5,000 RPS. High throughput is important for large-scale production systems such as recommendation engines, search systems, real-time analytics, fraud detection platforms. Throughput depends on factors such as model complexity, hardware resources, CPU or GPU batch size, network performance, serving infrastructure, auto-scaling configuration. In MLOps, throughput is continuously monitored along with latency to ensure the system can handle increasing traffic efficiently without performance degradation. Nice. Let's continue. Question 8. What is feature drift? Here's a strong way to approach it. Feature drift, also called data drift, occurs when the statistical distribution of input features changes over time compared to the data used during model training. This means the model starts receiving production data that differs from the original training data, which can reduce prediction accuracy and overall model performance. Example: a recommendation model trained on customer behavior during holiday season may perform poorly when user behavior changes after the season ends. Common causes of feature drift include changes in user behavior, seasonal trends, market changes, new application features, changes in data sources. In MLOps, feature drift is detected by monitoring feature distributions, mean and variance, null values, category frequencies. Statistical drift scores like PSI or KL divergence tools commonly used for drift monitoring include Evidently AIY Labs, Prometheus, Grafana. If feature drift becomes significant, retraining pipelines are usually triggered to maintain model performance. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.